Constructing a model. Mechanics deals with forces acting on objects and the motion of objects. Real situations can be quite complex, so a mathematical model is often a simplification of the real problem. For example, suppose a basketball player takes a shot. So the ball might travel like this. And let's imagine the situation when it's at this point. Its weight is acting downwards, and the object would be travelling in this sort of direction, and so there would be a resistance to the motion acting opposite, possibly air resistance, for example. The resistance R will change in direction as the ball moves along its arc, so it will always be directly opposite the direction the ball is heading in at any particular time. That makes it complex to model. However, at the low speeds that a basketball travels, it is probably negligible, and so this resistance can be ignored. On the other hand, a cannonball travels much faster. So the path of a cannonball might be more shaped like this. Here's the cannonball somewhere in its path, and the weight of the cannonball acts downwards, and resistance as shown. We might take the resistance away and model it as a horizontal force and a vertical force. And so what we have is a situation where we've resolved that resistance into components. Of course, Fy would actually act in the same direction as W, so it would be downwards, so it will be the negative of what it is. Remember, the resistance was heading this way. But these components would also change as we move along the path. Often, Fx and Fy would be taken as constant and not therefore changing along the path, or proportional to the components of the velocity themselves, or proportional to the squares of the components of the velocities. All of these things are simplifications that make the maths easier, but often we can get results fairly close to the real situation if we use those correct simplifications. And that being the case, we often want to have the simplest model to work with mathematically, that will actually give good results. The flowchart below shows the modelling process. So we start with a real-world problem, which may be very complex with lots and lots of variables. From that, we set up a mathematical model. We decide on our assumptions, we decide on our variables. And of course, at this point, what we're trying to do is simplify this real-world problem. We'll try to leave out things that would be very complex to work with mathematically. We then solve and we interpret the results. Is the answer reasonable? Well, if the answer to that question is yes, that's it, we report the solution. However, let's suppose the answer is no. So what we would do is reconsider our assumptions at this point, and we'd revisit the model and perhaps add in some other variable or another assumption, and then we would repeat the process. So we'd solve and interpret that and look at, is the answer reasonable? If yes, then we go and report the solution to that. Again, if it's no, we might need to add in some more assumptions and more variables.